All right, hey everybody. So we're going to be going over Solar exploiting log4j. It should take approximately 60 minutes. And as you're well aware, most of the security community, cybersecurity community is aware of log4j and the impacts it had back in 2001 and leading into 2002 as well, especially during the holiday season. Um, it's we found out about it around November, and usually everyone took action around late November to December and going into January as things changed. But I'm really interested in looking into this, doing a deep dive, as I'm pretty sure this issue is still prevalent among some organizations. So we'll go ahead and take a look at it. So task 1, CV 2021-44228 Introduction. On December 9th, 2021, the world was made aware of a new vulnerability identified as CV 2021-44228, affecting the Java logging package log4j. This vulnerability earned a severity score of 10.0, the most critically designation, and offers trivial remote code execution on hosts engaging with software that utilizes this log4j version. This attack has been dubbed Log4Shell. Today, Log4j version 2.16.0 is available and patches this vulnerability. The JNDI is fully disabled, supports for message lookup is removed, and the new DOS vulnerability, CV 2021-45046, is not present. However, the sheer danger of this vulnerability is due to how ubiquitous the logging package is. Millions of applications, as well as software providers, use this package as dependency in their own code. While you may be able to patch your own code database using Log4j, other vendors and manufacturers still need to push their own security updates downstream. Many security researchers have likened this vulnerability to that of shell shock by the nature of its enormous attack surface. We will see this vulnerability for many years to come. For a growing community supported list of software and service vulnerabilities of CV 2021-44228, check out this GitHub repository. This room will showcase how you can test for, exploit, and mitigate this vulnerability within Log4j. While there are a number of other articles, blogs, resources, and learning materials surrounding CV 2021-44228, the author of this exercise, and particularly parts to these, and we have some links here. Note from the author: please use the information you learned from this room to better the security landscape. Test systems you own, apply patches, and mitigate where appropriate, and help the whole industry recover. This is a very current and real-world threat. Whether you are a penetration tester, red teamer, incident responder, security analyst, blue team member, or what have you, this exercise will help you and the world understand and gain awareness of this widespread vulnerability. It should not be used for exploiting gain or self-serving financial incentives. I'm looking at you, big bounty hunters. Additionally, please bear in mind that the developer of Log4j package worked on the open source project as a labor of love and passion. They volunteer developers that maintain their project in their spare time. There should be absolutely no bashing, shame, or malicious towards those individuals. As with these, please further your knowledge so you can be a pedestal and pillar for the information security community, educate, share, and help. Read the above and deploy the target machine. So we'll go ahead and deploy it. And we'll check that it's complete. We recommend you use the TryHackMe web-based attack box for this exercise. However, instructions to exploit this locally are detailed. To start the attack box, click the blue Start Attack Box button at the top of the page, and I'll be using my own. All right, reconnaissance. The target virtual machine includes software that utilizes vulnerability package, offers a playground to explore the vulnerability. After deploying your virtual machine, you should find that the IP accessible within TryHackMe's VPN or through the provider attack box is the machine IP. To begin, start with the basic reconnaissance to understand what ports are open on this machine. This can be done within Linux distributions, Kali, Patriot OS, BlackArch, or any other favoriting of your choose with nmap command. All right, so this application presents on this target specifically uses ports that are not immediately noticed by nmap. For the whole picture purpose, scan all ports like this. All right, so we're doing a verbose scan, then we're doing a verbose with all ports, and scan the machine, determine what ports are accessible, what service is running on 8983, just name of the software. Okay, easy. So let's go ahead and use their attack box for now. It's really my last option to use their attack box, but I'm just having issues with the VPN. All right, back to learning here. Got reconnaissance. So let's continue on with that. Pretty sure you could still do what I was doing earlier with the recon tab here. Or not. Okay, let's set title. Oh, you can. Okay, good. There we go. All right, so then I'll grab the IP address. Paste it. And let it do its scan. So mark that as complete. And we'll give that a second to finish up. All right, so the full port scan still running. So what I did was I just did a targeted scan, which is going to use nmap, SV, we're going to get the service version on port 8983, and it's going to run against the IP address. So here we can see the port is open, the service is HTTP, and the version is Apache Solar. That's our answer. I'll go ahead and copy that and insert that here. All right, great. Moving on to discover. The target machine is running Apache Solar 8.11.0, one example of software that is known to include this vulnerable log4j package. For the sake of showcasing this vulnerability, the application runs on java.1.8.0 Explore the web interface accessible at this address here and click around to get a feel for the application. For more details on Apache Solar, please refer to the official website. This instance of Apache Solar is provisioned with no data whatsoever. It is a flat, vanilla, and absolutely minimum install, yet at its core, it is still vulnerable to the CVE 2021-44228. Take a close look at the first page visible when navigating to this IP address. You should be able to see clear indicators that log4j is in use within the application for logging activity. What is the dsolar logdir argument set to display on the front page? Okay, so what we'll do is we'll just go to that IP address here, open up Firefox. And we got to download something, so I'll download that. All right. Just come here, paste this and go. All right, you can see the Apache Solar console. What is the dlogdir? vlog.dir right here. So here we can see the location of that file. It's in var solar logs. Copy that. Put that over here. Download the attached files accessible in the top right corner of this task. You should see some example log files within Solar. Explore each file if just to get a feel for what is displayed in what logs. One file has a significant number of info entries showing repeated requests to one specific URL endpoint. Which file includes content, this repeated entry, just the file name itself, no path needed. Okay, so let's go ahead and take a look at the file. All right, here's the file, and they're asking which includes this repeated entry. All right, this one has a lot of info entries. So I'll say solar log. Let's check it. Great. And let's just look at some of these entries. Okay, very interesting. Moving on. What path or URL endpoint is indicated in these repeated entries? All right, let's see here. So here we can see that there is a query here, and it looks like it's being made at this location. It's also var solar data, var solar data. If we see more var solar datas. Multiple entries here for admin course. That might be it. So go ahead and check that out. Yeah, I think it's the admin course. Viewing these log entries, what field name indicates some data entry point that you as a user could control just the field name? Okay. So it looks like the path, maybe. Let's kind of get a hint from this. We're looking for something with about 6 characters. If I'm looking at this file, All right, just give me a sec. I'm gonna kind of give it a whack. All right, just looking at it real quick, you can see it has a parameters field here, and there's nothing in it. But you know, here you can see some parameter in here. It's an ID, and parameters are typically something that you would enter, that you provide. So that made sense for me to put that in there. All right, so next let's go ahead and move on to task 4, proofs and concepts. All right, note that the URL endpoint that you have just uncovered needs to be prefaced with the Solar prefix when viewing it from the web interface. This means that you should visit Solar admin course. You also notice that the params seems to be included in the log file. At this point, you may have already to begin to see the attack vector. The LOG4J package adds extra logic to the logs by parsing entries ultimately to enrich the data, but may additionally take actions and even evaluate code based off the entry data. This is the gist of CVE 2021-44228. Other syntax might be in fact executed just as it is entered into the log files. Some examples of these syntax are ISO name, sys username, log config parent location, environment path, environment host, Java version. You may already know the general payloads to abuse this log4j vulnerability. The format of the usual syntax that takes advantage of this looks like so. So JNDI, and then JNDI to do an LDAP query, and then the attacker controlled host to do a remote like reverse shell basically. This syntax includes that log4j will invoke functionality from JNDI or the Java name and directory interface. Ultimately, this can be used to access external resources or references, which is what is weaponized in this attack. Notice that the LDAP schema, this indicates that the target will reach out to an endpoint, an attacker-controlled location, in the case of this attack via the LDAP protocol. For the sake of brevity, we will not need to cover all the ins and outs details of LDAP here, but know that is something we need to work with as we refine our attack. For now, know that the target will in fact make a connection to an external location. This is indicated by the attacker-controlled host placeholder in the above syntax. You, acting as the attacker in this scenario, can host a simple listener to view this connection. The next question is, where could we enter this syntax? Anywhere that data is logged by the application. This is the crux of this vulnerability. Unfortunately, it is very hard to determine where the attack surface is for different applications, and ergo, what applications are in fact vulnerable? Simply seeing the presence of log4j files does not clue in on the exact version number or even where or how the application might use the package. Think back to the previous tasks. You already discovered that you could supply params to the Solr admin core URL, and now that you have a better understanding of how log4j works, you should understand that this is where you supply your injected syntax. You can simply supply HTTP GET variables or params, which will then proceed and be parsed by log4j. All it takes is a single line of text, and that makes this vulnerability extremely easy to exploit. Other locations you might supply this JNDI syntax: input boxes, user and password login forms, data entry points within the application, HTTP headers such as user agent X4s for other customizable headers, any place for user supplied data. All right, so let's go ahead and go to this location. So they gave us this directory here, just paste that in. We have a directory open already, so we'll just duplicate it. And then what we'll do is we'll just remove this portion here and then paste in our supplied portion. Like so, press enter. It doesn't like that I made a // and then here we can see might be able to do some type of curl request. Okay, it's very interesting. So if you would like more information on this JNDI attack vector, please review the Black Hat US presentation from 2016. All right. So just from my understanding, high level understanding is that JNDI was a function within log4j that can be abused to conduct queries, one to include the LDAP, where it will then process an LDAP request. And LDAP is a lightweight directory access protocol, which can be utilized to reach out to other machines via LDAP, or really it's to allow some type of connection to the LDAP database, and can be queried. And so essentially that's what we're doing to prepare your environment for the testing of this vulnerability and receive connections. View your own attacking machine IP address with the following code. All right, so we'll go ahead and grab our own IP address, which I want to say it's in the terminal when we started up. Yeah, it's right there. So our IP address is right there. We'll go ahead and click complete on that one. And we'll just verify it's the same. I'm pretty sure it is. Let's see here. So it's a little larger. And let's run that again. So we're looking for the one that's NA146. 146 should be here. Might be up here somewhere. Ah, here we go. 146. There it is. And that's the same IP address as this. All right, good. Now we're preparing our listener. So what we can do is we can go ahead and kind of close out some of these terminals, minimize this. We've got our terminal open here. See if we could open a terminal within this. No, it just opens up here. Okay. Well, hey, it is what it is. Let's try labeling some of these so I don't get confused later. See if it gives me the ability to edit this. Label it. Yeah, here we go. We can set a title for this one. So this is going to be mmap targeted. All right, and we got another one here. Terminal. I'll title this one as NC for cat listener. And then we could do this. C B 9999. All right, great. This also helps us later. So if I'm clicking around, trying to figure out which terminal does what, I can easily see it. All right, great. Complete. Now that you have the listener stage, make a request, including this primitive JNDI payload syntax as part of the HTTP parameter. This can be easily done with the curl command utility. So we're curling, okay, we want to access this directory, and then we want to pass along our JNDI query here. So go ahead and click this, go over here. Paste it in, enter. And looks like I missed my quote on that one. So just exit out of this. And run it again. Here you can see it did the curl request, and we should get some type of shell back on here. Note that due to the use of the $sign character in your syntax, you must ensure that you wrap the URL with a single quote, so the bash, your command shell line, does not interpret it as a variable. Additionally, you must escape out of the curly brackets with a single backslash character so that you are not misrepresented in the curl command arguments. All right, so I think we did that. Yeah, we did. Okay. Verify that you have received a connection with the following message. And we did not receive one, so let me look into this a little bit further. Oh, wait, we forgot to put your IP address in there. So let me put in my IP address and rerun the command. All right, so I punched in my IP address there, and then I press enter, and now we get our connection. So who am I? All right, so it's not very interactive, but we got something back. So that's great. Go ahead and complete this one. Complete that. All right, so exploitation. At this point, you have verified the target is in fact vulnerable by seeing this connection caught in your netcat listener. However, it made an LDAP request, so all your netcat listener may have seen was non-printable characters, strange-looking bytes. We can now build upon this foundation to respond with a real LDAP header. We will utilize an open source and public utility to stage an LDAP referral server. This will be used to essentially redirect the initial request of the victim to another location, where you can host a secondary payload that will automatically run code on that target. This breaks down like so. First, your LDAP query reaches out to an LDAP referral server. Second, the LDAP referral server springboards to the request to a secondary resource here. And then third, the victim receives and executes the code presented in that resource location. This means that we will need an HTTP server, which we can simply host with any of the following options, serving on port 8000. So we'll start our Python server, or any other web services. If you get stuck on any of the following steps, we have a video showcasing this as well here, but this isn't very difficult, right? So you just start their HTTP server. You can specify the port address for it, but we want to run that server in a specific location because that's where we would be hosting our malicious code. So let's continue reading here. Read and understand the attack chain above. Done. The first order of business, however, is to obtain the LDAP referral server. We will use the Marshall sec utility offered from this GitHub address. Ultimately, this needs to run Java. Reviewing the README for this utility, it suggests that using Java 8, you may or may not have successfully used a different version. But to play by the rules, we will match the same version of Java used on the target's virtual machine. If you're using the TryHackMe attack box, you do not need to follow the steps below. Move on to the next question. All right, so C steps to install Java 8 locally. We don't have to do that. Next, you'll need to receive the Marshall utility referenced previously. If you're using an attack box, navigate to the following. So we'll cd into this because it's already pre-installed. And we can do it from this location here. All right. C steps to download Marshall locally, followed only if not using attack box. So we already have it here. We must build Marshall with the Java builder Marvin. If you do not yet have Marvin on your system, you can install it through the package manager, not needed using the attack box. Okay, so we can go ahead and skip that. Please note the attack box for free users does not have internet access and won't install the Marvin package. Either subscribe to complete this lab through the attack box or install the Marvin tool locally, Marshall tool locally. With the Marshall utility built, we can start an LDAP referral server to direct communications to our secondary HTTP server, which we will prepare in just a moment. You are more than welcome to dig into the usage, parameters, and other settings that can be configured with this tool, but for the sake of demonstration, the syntax to start an LDAP server is as follows. All right, so in this location, looks like we're running this code here with our IP address there. Okay. Okay, so first command you're going to want to run, even if you're, in this case, I recommend at this point to utilize the attack box because it has stuff installed. You don't have to go messing around trying to install it on your Kali instance, which is probably up to date, and you'd have to like either downgrade some versions of some tools, or you may have some compatibility issues there. So just avoid that. Just use their attack box, okay? And you're going to want to run this command. So even if you're using their attack box, you're going to want to run this command. This is going to initiate the Marshall sec. And if you don't do that, well, then it doesn't build it and you won't be able to move on. But let me go ahead and scroll up a little bit. what that looks like. So once you run that command, you're going to, and I could just run it again, but you just take this, right? Just grab this. It's going to build the Marshall sec package, paste it in. I already done it, so I guess maybe it might just error out and say I don't need to do this, but you can see it's got the snapshot there, and that's going to be what we see in the next command here. And then it's going to do that, but it's already got everything, so it should be good. Next, start a Python 3 HTTP server on port 8000. We want to do this from wherever we're hosting the malicious code. So yeah, they'll probably tell us why, but here you can see the build was successful, and there was a snapshot of Marshall, and it's a jar, so this is like a Java script type of application. So next what we can do is we can just copy this command, and you're going to want to make sure that you change change this and put your IP address here, and do that to 8000, and then the exploit, I guess they'll tell us where that location is going to be in bit. So here you can see I have it right here. I kind of already pasted it in, but just grab that command, put it over here. Hopefully it runs, because it didn't run last time. And it's listening on this port 1389. So now what we can do is we just take this. This is like the flag. Copy that. Come over here. Drop it in here. And I'm starting a listener. All right. So now that our LDAP server is ready and waiting, we can open up a second terminal window to prepare our final payload and secondary HTTP server. Ultimately, the log4j vulnerability will execute arbitrary code that you crafted within the Java programming language. If you aren't familiar with Java, don't fret. We will use a simple syntax that simply shells out to running a system command. In fact, we will retrieve a reverse shell connection so we can gain control over the target machine. Create and move into the new directory where you might host this payload. First, create your payload in a text editor of your choice, Mousepad, Nano, Vim, Sublime, whatever you want to use, with a specific name, exploit Java. So here's the code here. Modify the IP address and the port number as appropriate. We are using 9999 as an example port number as before. For this payload, you can see we will execute a command on the target, specifically netcat e.binbash to call back to our attacker machine. This target has been configured with netcat for ease of exploitation, though you are more than welcome to experiment with other payloads. And so let's take a look. Here's the payload here. It's going to execute this command utilizing Java, and it's going to establish a reverse shell. Compile your payload with the Java exploit source code and verify it's successful by running the ls command and finding a newly created exploit class file. Remove the source 8-target 8 from the command if not using the attack box. Right, I haven't seen where that's at, but okay. Oh, okay, so that's really put it in here. Okay, so cool. This is where we're hosting it, and this is just kind of like the root directory. So I think we should have the ability to write to it. Let me go ahead and stop running this HTTP server for a second. We'll print the working directory. We can see this is the root directory. Sure, we'll just throw it in here if we can. We'll nano, and we will make this exploit Java. Okay. And then nano's open, and then next we'll just copy this code. And we'll edit the code a little bit using another port besides 9999. I think we can use something like 99991 or something. So we're using 9999 for our reverse shell right now. That's going to conflict. And our IP address here. And we can see the IP address on 25146. All right, good. So now we got that done. Just copy this and come over here, drag that in there, and we should be good. All right, cool. Go to Control O. Control O, save it, Control X, and close it. Then we're going to build out our, we're going to compile our payload here. So just grab this, come up here. So scripting languages, you have to typically build them out and compile them. And it looks like we got like an error. Let's see if it works. All right, well, so we'll just run this. All right, let me look into this a little further here. All right, so it's saying for us to, I don't know what the error is. Hopefully it works, but I'm just gonna go ahead and grab this. Move on. Paste that in. Sir, HTTP server which automatically runs on 8000. I didn't know that. All right, your payload is created and compiled. It is hosted with the HTTP server in one terminal. Your LDAP referral server is up and waiting in another terminal. Next, prepare the netcat listener to catch a reverse shell in any other new terminals. Okay. This one up. We'll name this one RV, so rev shell. All right, that's where we're going to be catching the rev shell. MVP, all right. 9.1, we changed it to 9.1. Finally, all that is left to do is trigger the exploit and fire it off. Our JND I syntax note changes in the port number, now referring to the LDAP server, and the resources we retrieve specifying our exploit. All right, so curl, then web server, all right. JNDI or attack host on 1389 for our malicious, like our malicious Marshall sec server that is then going to point to our reverse shell. Well, it's going to point to our HTTP server that's hosting Java that's saying to initiate a reverse shell. All right. Okay, so let's try it, see if it works. I had some issues with Java earlier when I was trying to compile it, so I hope this works. But I'm just going to put my IP address here. Okay. Put 10.10.25, and right now I'm just editing the code here in a pad. So curl LDAP. All right, this should be good. This should work. Copy that here. Open up a new terminal. Run the curl command. Run it. Exploit, and we're not getting anything yet. So this is it's not good. Yeah, let me look into this one. All right, so it actually worked. After I closed that first terminal that we opened in the very beginning, the one that was listening on 99999. Remember I said, oh, change it to 9991 because that might interfere. So I'm not sure how it interfered, but it did. Just if you have that original netcat listener for 99999, close it out, and then 9991's listener will then receive that connection. Who am I? Solar. So we're good. We're in. We got access. Perfect. So now we can go ahead and complete this one, complete this one, complete this one. Finally, all that is left to do is trigger it, right? And so our JNDI syntax, note that changes in the port number now retrieve LDAP servers and resources be retrieved specifying our exploit. Pretty cool. Modify your attacker IP as appropriate. Run the above command and you should get that listener. We have now received the initial access and command and control on vanilla, freshly installed Apache Solar instance. This is just one example of many vulnerable applications affected by this log4j vulnerability. At this point, a threat actor can realistically do whatever they like to do with the victim, whether it be privilege escalation, exfiltration, install, persistence, perform lateral movement, or any other post-exploitation, potentially dropping cryptocurrency miners, remote access trojans, beacons, and implement or even deploy ransomware. All it took was a single string of text and a bit of setup with the freely available tool. This is precisely why the internet has been on fire during the week of December 9th, 2021. Please hug any incident responders you know. Yeah. Troubleshooting. After receiving a reverse shell, feel free to experiment with other commands that you can run with the exploit Java payload. As an exercise for the reader, you can get interpreter shell loaded. How about Empire Agent? They call it Strike Beacon. You can go ahead and do that. Right now, we just ran, right, so this is our exploit right here. And so it's just running a netcat listener, but you can also have it just run some type of shell command, some type of other, just a regular like rev shell, like bin bash, something like that. You can have it get a file from your HTTP server that's malicious and then run that file to get that interpreter payload. But there's just a few other options you can do. I'm not going to go into those because those take more time and this videos are getting long enough as it is. All right, so persistence. Now that I've gained a reverse shell connection on the victim machine, you can continue to take any actions you might like. To better understand this log4j vulnerability, let's grant ourselves better access so we can explore the machine, analyze the affected logs, and even mitigate this vulnerability. You may have noticed from earlier's nmap scan that SSH port 22 was open on the host. We did not know any username or passwords at this point, so trying against that protocol would be useless. But now that you have code execution as a user, you could potentially add private keys or change passwords. Check to see what user account you're running as in the context of the reverse shell. That's exactly what I did. It's Solar, right? That's the first thing you do when you gain access. You hope it says root and you're done. Right? All right, put that in there. If you like to stabilize your shell for easier ability in typing commands, you can use the usual upgrade trick, assuming you are running as a bash shell. If you're running with ZSH, you'll need to start your netcat listener within a bash subshell. It should be easy enough to re-exploit. So we can just run this Python 3 to just more stabilize our shell, make it easier to interact with. So just paste that in. And you can see now we have this more interactive shell. You can also use this right here. Right. I that backgrounds it. And you run these other commands I don't feel like running. You now have a stable shell where you can safely use the left and right arrow to move around and input up and down arrows to revisit command histories, tab for autocomplete, and safely use the C, Control C to stop running programs. Check super user permissions for your convenience. In this exercise, you should have used sudo privileges without the use of any password. So sudo -l, see which commands you can run using sudo -l, and here it says you can use any commands, no passwords, extremely insecure. If you like to grant yourself persistence and access into the machine via SSH, momentarily become root and change the password for the Solar user to one of your choosing. This way you can use SSH in as needed. So here, sudo bash password Solar. So we're going to change the user's password, sudo bash, or we're sudo bashing. So we're taking our bash shell and we're kind of like upgrading it to root, right? So now we got this root shell and we use password Solar to then set that password for root to Solar, I believe. Let's see. Yeah. In another terminal window, you can SSH into the machine with your credentials. All right, so I'll just come over here, open this up, SSH Solar. And 10.10.125.189. Yes. Password. All right. So let's try this. All right, give me 1 sec. Okay, so actually right here you put password Solar. So when you type password Solar, what should happen is it tells you enter new Unix password, and that's when you actually will enter that password, right? So, and mine was password Solar because I totally did not pick that. All right, so now I've updated it. So now if you put password, right, space Solar, looks like it doesn't let me in. Let's see if I can get it now. No, it didn't like it. Okay, let me try this again. Now we enter the new password. I'll just put password and password. All right, good. Now we come here, put in just Control C. Just Control C this one. All right, do it again. Password. Permission denied. It may be that Solar doesn't have permission to actually SSH in. Take a look here. Yeah, that's interesting. Do that. Or it may be that I didn't type Solar incorrectly and I put an A after it because I want to type it incorrectly and realize that I actually typed it incorrectly. Oh, geez. All right, so now when I put it in, it should work. Yeah, it worked. All right, we're in. So good. We have an SSH connection. It's a lot better. Moving on. Task 7, detection. Unfortunately, finding applications vulnerable to Log4Shell is hard. Detecting exploitations might be even harder, consider the unlimited amount of potential bypasses. With that said, the information security community has seen an incredible outpouring of effort and support to develop tooling, scripts, and code to better constrain this threat. While this room wouldn't showcase every technique in detail, you can again find an enormous amount of resources online. Below are snippets that might help with these efforts. So here's local based off hashes for log4j. I'm pretty sure you can run your nested scans as well to determine that. Local based off hashes for log4j, listing of vulnerable jar and class hashes, local hunt for vulnerable log4j packages in PowerShell, local ER rules, which kind of like just regular hashes. As a reminder, a massive resource is available here. It's Reddit. To explore your own logs, use your SSH connection or reverse shell to move into the directory where the solo logs are stored. You already know what that path is. You gave it an answer 3. Okay, so we could SSH into that, and that was task 3. Okay, let me take a look at that. Oh, right here. Solo logs, I believe. Is that where it's at? The admin core. Let's go here. cd paste to this ls. Yeah, that's probably it. That's where the logs are. Okay, complete. Review the logs that you know is affected by log4j vulnerability. Give me a hint. Cat. All right, so we'll take this command, copy, come over here, drop that command in there. Got the so log. All right, cool. It's log here. Let's take a look at it. I'm gonna run that command again because there we go. All right, what are we looking for? Notice that the JNDI attack syntax included in the log entries. If you like to experiment more, try some of the bypasses mentioned in the task below. All right, so let's see if we could find that JNDI query we did. And just taking a look at this. Yeah, I don't see it yet. I do, well, no. Ah, here we go, found it. Look at it, JNDI right here. This is when I messed it up and I put, it says your attacker IP address, right? And then we corrected it, and then here's the actual JNDI query, right? And so when it got put in the logs, then it executed that query using JNDI and its ability to do LDAP queries to then query our malicious HTTP server, which then had it point to our malicious secondary malicious HTTP server, which then told it to execute Java code, which was then actually a reverse shell. So kind of complicated, but it's a lot of back and forth. There's some great images on Log4j too. So if you're still confused, just Google it and take a look at those images to help you understand it. All right. Bypass. The JNDI payload that we have showcased in the standard typical syntax for performing this attack. If you are a penetration tester or red teamer, this syntax might be caught by web application firewalls, WAFs, or easily detected. If you are a blue teamer or incident responder, you should be actively hunting and detecting that syntax. Because this attack leverages Log4j, the payload can ultimately access all the same expansion substitutions, and templates tricks that the package makes available. This means that a threat actor could use any sort of tricks to hide, mask, or obfuscate the payload. With that in mind, there are honestly an unlimited number of bypasses to sneak in this syntax. While we will not be diving into details in this exercise, you are encouraged to play with them in this environment. Read them carefully to understand what tricks are being used to masquerade the original syntax. There are numerous resources online that showcase some examples of this bypass with a few offers below. So here we have something that's kind of obfuscating it, and it's very complicated. Okay, note that the use of RMI :// protocol is the last one. This is also another valid technique that can be used with the Marshall-Sec utility. Feel free to experiment. All right, that's cool. Additionally, within the log4j engine, you can expand arbitrary environment variables. If this wasn't already bad enough, consider the damage that could be done even with remote code execution, but a simple LDAP connection and exfiltration of the env AWS secret access key. For other techniques, you are strongly encouraged to do your research. There are significant amounts of information being shared on Reddit. Gentle reminder for use of knowledge is for good. You know what they say, with great power comes great responsibility. So read through this. All right. Task 9, mitigations. All right, so now that you have acted as the adversary for a little bit, please take off your hacker hat and let's mitigate the vulnerability on this vulnerable machine. Review the mitigation techniques below on the Apache Solr website. One option is to manually modify the Solr in SH file with a specific syntax. Let's go down that route for the sake of showcasing this defensive technique. If you want to directly SSH the machine, the credentials are vague as username and are vagrant, and the username and the password is the same. Okay, so determine where the Solr in SH file exists on this target file machine. You can do this rapidly with the following command. So yeah, this is the locate command, my favorite. Let's go ahead and grab this. We have a SSH terminal open, so we'll do that. I don't know if we will have a permission issue with this Solr user. I think we'll be good. So let me just paste this in here. Oh, actually, this is the same one we're looking at. All right. Well, we have the SSH one. I'm not going to go looking for it, but either way, we're in the machine, right? So we're in the machine. We've located the file. It's here, right? And there's another one that kind of sounds like it. It's here. All right. So where's the full path to that file? And here it is right here. So grab this, copy it, drop it in here. All right. The Apache Solr website security page explains that you can add this specific syntax in the Solr in SH file. Okay. Modifying the Solr in SH file within a text editor of your choice, you'll need to do a sudo prefix to borrow root privileges if you're not already root. And we're already root in this one, but if you weren't, you'd use that. So here we have this command here. It looks like it's going to set the no lookup to true, meaning that it's not going to do any lookups utilizing JNDI. I'm assuming, right? Okay, looks like that went through. Modify the Solr in SH file with a text editor of your choice. You'll need to use sudo prefix to borrow root privileges if you are not ready. Okay, scroll at the bottom of the file and add a new line with the above syntax, save and close. Oh, okay. Oh, okay. Actually, that's not what we're supposed to do. Okay, so we're actually supposed to enter this into that file, which we did not do. So let me do a nano. Or actually, we'll just go ahead and we got to go to that file first. So it's in the etc default Solr. So we need to get into this file directory, or actually we don't even need to do that. We can actually just nano it from here. So copy nano. come over here, paste this in. Error company. Okay, so let's go to our SSH session because we're having some issues with that. All right, so here it is. We're looking at a log file earlier. Remember, this is actually the SSH session here. So let me scroll down. So here I can do it. Just put nano, and I can just drop in the path. Oh, we're in. All right, cool. So here it is here, and we'll just scroll all the way to the bottom. I'm like doing control down arrow, just move quickly to the bottom of this. All right, here you can see configurations we can set, and we'll just copy this baby here and drop it in there. And then we'll do control O, save it. Oh, we got permission denied. Should ran sudo. No. All right. Got to run the command again. So make sure you put sudo in the beginning. Now we should have no issues with this. And just remember, control down arrow gets you down to the bottom really quickly. Grab this command here, drop it in there. Control O, save, exit. All right. This process may vary between installations, but for the server, you can restart it. You can restart it with this. Okay, so we come here, done. Over here, grab this, copy it, run this command, paste it, restart the service, restarts it. To validate that the patch has taken place, another netcat listener as you had before, and spin up your temporary LDAP referral server and HTTP server again in the separate terminals. You'll want to recreate the same setup to re-exploit the machine. If you need a refresher on the command syntax, please scroll up to task 5. We don't, and we don't, because what we're going to do is we're just going to rerun the curl command. We have everything still running. The only thing I'm going to do is, obviously, we have this here. This is the netcat listener we had running before. Go ahead and exit out of that. All right, we have our SSH session anyways. Start this up. Come over here. This is where we did our curl command. Come back over here, drop the curl command, and we should get an incoming connection. But we don't. We don't, because I never did the lookup. We really exploit the server with the curl command, right? You should have no request made to your temporary LDAP server. Consequently, no request is made to your HTTP server. No reverse shell sent back to your netcat listener. Verify that the Apache Solr instance has been mitigated against the log4j exploit. So it's been mitigated. We didn't receive anything. Wah, wah, wah. All right, text 10, patching. At the time of recreating this exercise, the Apache Solr 8.11.1 has not yet been released with a formal patch for CV 2021-44228. Alongside many other software providers, the industry is frantically scrambling to patch their software and push it downstream to end users as quickly as they can. Please be understanding of this frenzy. There are so many potential places that Log4j vulnerabilities could be present. We may never see the end of vulnerability for a long time. The onus is on you, on me, and each and every one of us to raise awareness of this incident and hold the community accountable for actively responding to it. When the time comes, roll out the patches that have been made available and continue to hunt for instances of this vulnerability. It takes a village. Where appropriate, please ensure that you patch logging log4j package to version 2.16.0 or higher as new releases come out and are available. In versions 2.16.1.0, JNDI is fully disabled, support for message lookup is removed, and the new DOS vulnerability is not present. Download the resource there. If your responsibility for identifying vulnerable services that use log4j, there's a list of a few majorly affected service products here, and the list is huge, right? It's not just Log4j itself and the Apache servers. It's also other applications that use Log4j, and there's a lot. So Huge attack surface complete. We'll move on. All right, 11. Thank you for clicking all the way to the end, and I certainly hope that you read these parting words. This exercise is brought to you with the wholehearted intent that it improves your awareness and learning and understanding of this vulnerability. For the right reasons, the material presented to you cannot be possible without the incredible contributions from security researchers, incident responders, system administrators, and security practitioners all throughout the industry. We owe you incredible thanks to the profession, all working sleeplessly around the clock, foregoing the weekends and time with friends and family to better protect the entire internet. While Hollywood hacking is cool and flashy, cybersecurity is a team sport. Please review the external resources and make this community a better place. Good to do great things. Done. Hope you enjoyed this video. Please like and subscribe for more content. Kind of shifting between OSP content and CVEs and kind of wanting to cover both of those at this point. So hope you enjoyed it. Danny, out.